Hello everyone and welcome to our lecture 17 unit circle mini test solving. So here is the mini test for those of you who just want to solve it. And let's go ahead and solve the problems. So to start we had to convert between the units, 120 degrees into radians and 3π4 radians into degrees. So we either remember the formula or we just do the cross solving. So for the first example I have written down the degrees to radians, so our conversion, and 360 and 2π. So here I'll insert 120 for degrees. I multiply crisscross, so 2π goes to 120 and 360 goes to radians. And while that is gone, I already simplified the 2 and 360 to become 1 and 180, and we get something like this. Now, here don't get confused, rad here and deg were the variables that stood for the values here. So technically I'm isolating a variable labeled as rad. I could also just use x, would make it a lot simpler, but yeah, that's kind of my fault here. Anyway, I isolate rad by dividing by 180, and we get 2/3 pi is rad, so 2π thirds radians is the converted 120 degrees. Now for the second example, we have 3π4 radians into degrees. So again, cross multiply, again simplify 2 and 360 to 1 and 180, and we get pi degrees, or pi deg, or pi x equals 180 times 3π divided by 4. So we cancel pi on both sides, and we simplify the 135, and we get 135, sorry, my fault there. I got carried away with some other numbers. Basically, the degree value of this is 135 degrees. Basically, just using the formula or crisscross way of solving. Next, we had to write the coordinates of the points where the hand at the given angle intersected with the circumference. So since we are all, especially you, are so smart, I think we can rapid fire this one. So I set the brackets in form of coordinates and already filled in the angle values. I used square brackets to make it easier to differentiate between which bracket encompasses what. So the function brackets are replaced with square brackets for this one, just so it's easier for you to understand it. And I already filled in the angles. I put them all in the calculator under the degree setting, and we will get 1, 0 for the first one, -1 divided by square root of 2, and 1 divided by square root of 2, or if you factorize it, you get square root of 2 divided by 2 as y coordinate and minus square root of 2 divided by 2 as x coordinate. Depends on which system you were using, both were fine. So either this one or the factorized form, as long as the first one is minus and the second one is plus. And lastly, cosine 300 and sine 300, we get 1/2 as x coordinate and minus square root of 3/2 as the y coordinate. So we used the calculator and made it look very simple. However, for the next one, because this one was too easy, we're not gonna be able to use it. So solve without a calculator a sum of sine of 30 degrees and cosine of 60 degrees. So we use the table and we see that both of them have a value of 1/2. So when we add that together, we get 1, which is the answer. Now for the last one to solve today, tangent of 45 degrees multiplied by tangent of 225 degrees. Now, for the table, we know that the first one is 1. We check that, or we just use the Pythagorean theorem or whatever other rule we have. Now for the second one, since it's more than 180 degrees, and we know that a period in tangent graph is 180 degrees or 1π, we can subtract from this angle our 180, and we will get 45. And 45, as we know, tangent of 45 is 1, so we get 1 times 1. You can fact check that in your calculators to make sure that you solve it correctly. And with that, this is it. Thank you so much for tuning in to this very, very short mini test solving. I hope you liked the video. I hope the mini test was not too hard. Frankly, I think this one was one of the easiest ones so far. And yeah, thank you, and I'll see you all next time. Bye-bye!